Okay, so this is about fractional exponents. So previously looked at 8% simple interest rates versus 8% compound interest. There's also a third option, investing in a money market account, which offers 8% annual interest compounded quarterly. Now, this is tricky, but I'll give you the formula. And if you use the formula correctly, you'll be fine. So compounded quarterly. So if you think about how many months is a quarter? If you do things, three, right? Because 12 months in a year, you do something 4 times a year, 12 divided by 4 is 3, right? So what this means is that the money gets added every 3 months. And when I say money, let me rephrase that. The interest on your money. When you guys hear the word interest, what do you guys usually think of? Just throw it out there. Yeah. Yeah. So basically, like for example, if I loaned, like say Davis, $1,000, right? Like today, just like, Mr. I need money. Okay, here's $1,000, Davis here. But now I could just be nice and say, hey, just pay me back 1,000 whenever you can. Or I could be kind of more strict and say, okay, we're kind of the payment plan, and I'm going to charge you 5% interest. So he's got paid a little bit more than $1,000, right? So I'm gaining money, right? So it's interest is kind of a way of gaining money, and you have to apply that percentage at certain times. You're like, maybe I'll say every year I'll apply 5% interest, or may I say like a credit card? That's every month, right? Every month they apply the interest. So that's what interest is, and we're doing it quarterly. So every 3 months we're going to be adding money to the account. So what does quarterly mean? It means every 3 months. How many times a year? Well, 4, because a quarter is 4, right? So that should be pretty straightforward. When interest is given quarterly, you do not get the annual amount of 8% each quarter. Instead, you get 8% divided by 4. So it's 2%. You take that 8% and you divide by 4. So you're chopping it up 4 ways. So say, for example, you invest $1,000 in a money market account. Which equation can you use to represent the money in the account after a certain time? What does your variable represent? Let me give you the formula here. It's not quite easy. It looks kind of complicated, so bear with me here. Okay, here's the formula. It's a little confusing. I will give you the formula, don't worry. I'll even tell you what these things mean. Okay, but you gotta know what to do with it. Anyone know what the P stands for?
Percent.
Not quite. Principal, good. Principal is going to be the initial amount, the initial deposit. So that's the principal. What do you think R represents? Yeah, it's going to be the interest rate. It's expressed as a decimal. So if you have 8% interest, what are you going to put for R then? Not 8, but R equals what?
0.
Exactly. Oh, Dave's good, and I'll get to you 100. No, I'm going to give this to you. Yeah, I'll give that to you. Just that. Good. No, because we're going to divide. So hold on to that thought. N is going to equal the number of times the money is compounded each year. So each year, the money is compounded how many times? 4, right? And what do you think T represents, guys? Just should be intuitive. Time in years, right? One more variable. A. I'll squeeze A down here. A is going to be the amount of money after T years. So let's recap this. There's a lot going on here. It's not hard. Just plug and check.
So there's 5 variables: P, R, N, T, and A. Right? P is the principal, the amount of money you start with. So this question here, how much money I start with? So that's going to be P. And we're doing this, and the interest rate's how much again? What's our percent interest? 8%. So R is going to be 0.08. Now to answer your question, Hunter, we're doing this quarterly, right? Quarterly means 4.
Yeah.
So so you don't put 0.02 here, you put 0.08, then you put 4 down here. Yeah. Overall, it becomes 0.02. Okay. So then the base would be 1.02. Question?
Yeah.
Let me keep going, and I'm not clear if that's keep going. Okay. Alter X of NT. N is in their type of compound, and T is in review. So let's say you invest for 2 years, right? You invest for 2 years, but you're compounding quarterly. When you're compounding quarterly, you invest for 2 years. How many times is money being added to your accounts? 2 years will compound quarterly. 8 times, right? That's why the exponent has to be NT, because you have to raise this multiplier to the 8th power if you're adding money 8 times. And divide by n, because again, you're doing it at 8% spreading over 4 years. And then A is the amount of money you have after the time sense.
Okay. Still, there are even more complicated formulas than this. That's something you won't touch until you get to pre-calculus. Like if you look at a home loan or investments, that's a much different complicated formula. And it's funny because the people who actually, like if you talk to a loan broker, my brother's a real estate agent, he doesn't even quite know the math fully. He knows how to compute it. He knows how to punch in a calculator or a computer, but doesn't quite understand all the math that goes into that stuff. So it's kind of interesting. People work with stuff. They know the numbers, but they don't like know all the fine stuff of the math sometimes. But anyway, so now let's answer this question.
You don't need to know that formula.
I'll give it to you. You don't have to memorize it. Okay. You need to know how to use it. Okay. So let's look at this now. A equals P. I'm going to write this again one more time. And let's see if you. Sorry, I know you said an answer, but let's work it out. So A is going to equal what? The principal, which is 1,000, right? 1 plus 0.08 divided by 4 raised to the 4 times 20th power. Does that make sense? Yeah. And again, it's a matter of just knowing how to use it. And then you just plug in the calculator. That's all. And what do we get for A? I'm going to get my calculator out as well. Okay, so I'll have it open. Okay. So 1,000 times 1 plus 0.08 divided by 4 raised to the 80th power. Okay, you see you got 20,000? Someone said 20,000? That doesn't make sense, doesn't it? No. Should be, you got 20,000? Let me see what you did. I'll come by. Okay, good. And 44 cents. Hold on, Jack, let me see what you did.
Oh, you did all the operations. Yeah, give it I got that. This is multiple. Oh, okay, so it's calculated. I don't know. Oh, you did 20. What did you do? 0, 0.
You do 80% interest because they're saying who's bankrupt you, so you don't have that.
Yeah. All right, guys, let's move on. Okay, let's try another one here, guys. So Chase Bank offers 3% interest. Guys, quiet, please. Chase Bank offers 3% interest for your savings account. If you close your account mid-year, the amount of interest will be prorated. So Josie wants to deposit $500 in the Chase account. Ryan equated shows amounts, blah, blah, blah. So it's really simple. The amount of money will equal 500. Now it's compounded annually, so n is 1. Because annually means once a year, right? So n is 1. So you do 1 plus 0.03 divided by 1, which is 0.03, obviously, raised to the 1 power times t, or just say times t, or x. Here we go. So you don't really need that divided by 1. You can just do that. That's totally fine. That works. So that's your answer there. Or 500, 1.03 raised to the x power. Now, if x means half, that means that it's only be 6 months. 1/3 would be 4 months, right? Because 12 months in a year, obviously, right? Because x is the number of years. What would 1.5 be for x? How many months is that? Yep, 18 months. You still plug in 1.5, 1/2, 1/3, just so you know it means 18 months. What is a reasonable domain for this situation? So domain is going to be your x values. Well, it says here she closes the account mid-year. So mid-year is how many months? Yeah, or if you wait like after 3 years, 3.5. So a reasonable domain will probably be like 0.5, 1.5, 2.5, and so forth. Because she's always going to close the account in the middle of the year. So you do 2, that's 2 full years. She's not closing at the end of the year, she's closing at mid-year. So it's going to be a 0.5 somewhere next. That'd be a reasonable domain for that situation. So, and it can't be negative because you have to go back to the future. But it always has to end in 0.5. So you're dealing with mid-year. Okay, let's keep moving. Okay, this is a new thing for you guys. I highly doubt any of you guys have seen this. Okay, fractional exponents. So that's when you have x. You have something like this here, or x raised to 1/n. Okay, Hunter, go ahead.
This is just on the mouse. What's the reasonable domain of things provided?
No worries. Anything ends in 0.5. Like 0.5, 1.5, 2.5, 3.5, 4.5, 5.5. Because you're closing the account mid-year. Because mid-year means you're going to have to add. You can't do a whole number because the whole number will be at the end of the year. Okay, so and 0.5. All right, so this is something you guys haven't seen yet. I'm going to teach you guys right now. When you have a square root, it's the same thing as saying this. Or if you see this here, it's the same thing as saying that. In general, if you have this, it's like saying that. So these are fraction exponents. So the square root, believe it or not, is an exponent. It's probably been taught to you that way. You probably learned square roots like, oh yeah, you're 25 square root 25 is 5. I'm not sure how to find middle school. I don't teach middle school now. Or square root 16 is 4, right? 4 times 4 is 16. But believe it or not, square root is actually an exponent, and you have to follow the order of operations like you would for an exponent. Like for example, if I have root 9 plus 16. If you think about it, it's really like saying 9 plus 16 first, and then you square it afterwards, right? So what's 9 plus 16 versus 25? 25 is 5. What if I did it individually? What would you get? You get a different answer, right? You get 7. So clearly that's wrong because we're supposed to actually take everything inside of parentheses first. So it's like an exponent. So you have to respect what an exponent. Same thing if I have like roots, but root 25 plus root 16. Can I just combine these to root 41? No, because you have root 25 first and root 16 first before you add them, right? So it's like an exponent. So radicals are exponents. So in this case, the cube root of 17, the cube root of 17 is going to be written like this. 17 to the 1/3 power. And I can even prove it to you in the calculator. If I do cube root, which is math option 4, 17. It's gonna be this nasty number, right? If I do 17 raised to the 1/3 power, same thing. So totally the same thing. So when you write this as an exponent, that's 5 to the 1/2 power. What would this one be, guys? If you have the fifth root.
1/5, good, excellent, 1/5.
Excellent.
By the way, this is an incredibly important skill as we move on to calculus. Calculus in those 2 years from now.
You may not even do it. Maybe it'll be stats. I don't know, or stats. But the thing is that you have to be very fluid between radicals and fraction exponents, especially in calculus, because you wind up applying all these calculus principles to these types of equations, and it's going to be easier to work with these types of numbers. You can convert to a fraction exponent. So you have to be very comfortable with fraction exponents. So we have to, be very fluid and go back and forth between those two. So let's look at this one here. We know this is true, obviously, right? Right. So, like for example, if I have 2 squared cubed, what's that going to be? 2 to what power? If I use that property, 2 to the 6, right? Exactly. Multiplied exponents. It's kind of the same thing here. It's the same thing here. It's 16 to the 1/2 cubed. Or, because it's said right 2 ways, 16 cubed, then raised to the 1/2. Now let's think about it. Let's back up a little bit here. We just talked about 1/2 being square root, right? 16 to the 1/2 is the same thing as root 16. We just talked about that. What's root 16, guys? So then that's 4 cubed. And what's 4 times 4 times 4? If you did 4 times 4 times 4, you get 64. Now this one's more nasty. 16 times 16 times 16. That's a little crazy. And then you have to square it afterwards. Well, I'll punch in the calculator. 16 times 16 times 16, which is 4096. Square that is still 64. Yeah, still the same thing. Or you could do 16 raised to 3/2 power. Yep, that's all. Okay, so now what are you guys going to do? Do parts A through F in your groups. You're going to write it 2 ways. So like, for example, for part A, I'll do it again with you guys. 10 squared raised to the 1/3. Or 10 to the 1/3 raised to the 2nd power. Do this for the other 5. You're not evaluating at all.
You're just writing, that's it. Or rewriting. So you're rewriting it so that you have parentheses, something raised to some power, and another power on the outside. So the denominator and the numerator. Yeah. So well, if you might have worked it out, so you have to square root 16. Okay, just 4. The 4 cubed, 4 times 4 times 4. So, what I asked about it is about that. Exactly. Okay. That way, you're learning how to break the next one. You guys are breaking down excellence. All we're doing breaking excellence. So, yeah, so I want to do this. I think this is nice for starting. So that's good.
So there's another X versus absolute third. Yeah, sorry. That's good. Okay, yeah, that's good. Okay, it's not serious. Yeah. This one I raised. That one I raised two. Yeah, yeah, exactly, yes. Exactly. Or this looks like seven. Yeah, it's not. What is the? Yeah, let me show you the answers. Can we just text on the table on the outcome?
Is this one just the same as the video? Or is it just?
Yeah, or no, or why did three raised plus? And then on the outside.
Is one third supposed to be?
No, you can do inside or outside. So, yes.
Did you do why or one third?
No,
Or
that's way better. So that's the one half raised to 5 or
what?
two to the 5 minutes. Because that's the bulk of it. Or here. Yeah. That's yes. Yeah. Okay, so let's do this. That's a maximum. You guys, let me help you out because I may have goofed a little bit. Question?
Yeah. Great.
Yeah.
That's what 2 to the 1/2. This word is 1/2. 1/2. Then raise it. Or is the fifth power raised to 1/2. Like this would be 5 to 1/2. Yeah, guys, let me help you out a little bit. I kind of
Sorry.
Yeah.
Is it?
actually one no of 1/5.
Yeah. That'd be one.
So the first one's on, the second one's back.
Yeah.
You guys, let me help you out because I think I may have not explained something correct. That's my fault.
Let's back up a little bit here. Okay, so here's a general thing that's happening, and I probably messed up. It's my fault. It's going to be like this: the nth root of x to the m, or the nth root of x, and that raised to the m power. Because this is like saying x to the m raised to the 1 over n, or it's like saying x to the 1 over n raised to the m. So what happens is that this is always going to be the root, and that's going to be the not the power, but like your exponent. So let's look at b, for example. That's 9 to the 1/3 power and raised to the 4. Or you do 9 to the 4 first and raise to the 1/3. Does that make sense? Okay. Let's look at d. Square root is 1/2. 2 to the 1/2 raised to the 5th, or you do 2 to the 5th first. Do not put the 5. So the 5 has to be the numerator. Okay. 5 has to be the numerator. The root has to be the denominator. Okay. The root is the denominator. The exponent is the numerator. Okay. Like here, 5, 6, 7 halves. Or let's back up a little. Let's look at c. C is a good one. 5th root of x cubed. That right there is your denominator. That right there is your numerator. Okay, that's always going to be true. That's why we say the nth root of x to the m equals x to the m over n. That's why we say that. So in this case, that's x to the 3/5 power. But when we have to write two ways, you could do this: x to the 3 1/5, or x to the 1/5 then cube. That's what you're supposed to write for part C. Does that make sense? We're trying to see the connection, hopefully. Okay. Let's move on to the next page. After this page, we're done, and you guys can start homework. Well, actually, there's still the homework quiz we have to do. That's fast. Okay. So let's read the next part. Okay, guys, quiet, please. Actually, let me have someone help us read. Clay, you want to read B82, please? Yeah.
Answer the following questions using what you know, what you not know, how to read like a tax class.
Okay, so avoid using a calculator, right? So here's the deal. When you have something raised to the 1/2, that's negative 27 raised to the 1 power. And then we're going to do 1/2, right? But what's 1/2 as a radical? We talked about this already. It's square root. Can you square root negative 27? That's undefined. However, this one is like saying the cube root. What three identical numbers multiply negative 27? Negative 3. Yep, negative 3. Because negative 3 times negative 3 times negative 3 equals negative 27, right? So you got to be mindful about the denominator. So let me put this up top. So like Blue Angels practicing or something, or what's going on? Yeah, cool. Yeah.
What is it?
I don't know. It might be. I mean, Blue Angels usually Fleet Week is usually beginning of October, so maybe they're practicing. I don't know. Could be. Okay. Hold on, guys. Sorry about that. Okay, here we go. All right. So, really quickly, when this is even, that's going to be an even root. Like square root. When that is odd, that's going to be an odd root. Like cube root. You can odd root negative numbers. You cannot even root negative numbers. Can't happen because you can't multiply a negative number even number of times and have it be negative. It's going to be positive. So given that negative 27 raised to 1/3 power is negative 3, now let's do this one here. Is that positive or negative or does not have a real solution? Well, here's what how you can think of this. Does that make sense? Why decomposed?
Ellie, can you supplement this here? Thanks. Yeah. So let's see how I decompose this, right? You have 2/3. So this is the part where you have to be really comfortable with like decomposing fractions. 2/3 is 2 times 1/3, right? Or 1/3 times 2. Actually, that's not a big deal. 2/3 is 2 times 1/3. Or it's 1/3 times, sorry. Actually, yeah. I don't know what I'm going to say. Yeah, so it's 2 times 1/3. There you go. Or 2/1 times 1/3. So that's what's happening. Or you put the 1/3 on the outside. Or I'm sorry, on the inside and 2 on the outside. So that's why I decomposed it. That I know is -3. So what's -3 squared?
9.
No, so it's positive. Yeah. Sorry, Dave's good.
Would you rather us cube with negative 27 and square?
Yes, exactly. Yeah. So it's clearly positive. Okay. Now, this can't be done. This is going to be a weird decimal. Well, I'll do in the calculator with you guys. But yeah, the 4th root of negative 27. Can I multiply a number 4 times and have it be negative? No. 5 you can. They're all negative. But I can't. If I multiply 4 even numbers, it's even. 4 negative are still even, right? You can't even root. Yeah, you can't even root negative numbers. Now, later on, I don't know if we'll do it this year or maybe in pre-calculus, you will learn that you actually could even root negative numbers, but you put something called an imaginary number. We're not going to talk about that now. We'll talk about that down the road. But it won't be real, put it this way. It won't be real. And by the way, if you're curious, let's see what the calculus says. Here's what the calculus is going to tell you. Negative 27 raised to the 1/4 power. It's going to say error, not real, right? Let's change that to a 5. Weird decimal. There you go. Because if you multiply negative 1.93 by itself 5 times, like I'm not going to do it, but if you do it, you'll get negative 27. Okay. Well, I want you guys to answer this last one in your groups. I'll walk around, see how you guys are doing, and then we'll do the homework quiz, okay? So let's answer these 3 questions. Okay. Kind of interesting, actually. I have a dichotomy here. So what does it mean to not be real? Can't find 2 real numbers that multiply negative 100, right? 31.6. So the first bullet point, is Alex right? Yes. Yeah. He is correct. So here's what you'd want to say for the first bullet point. Alex is correct since there are not 2 real that are identical and multiply to negative 100. We know 10 times 10 equals 100, and negative 10 times okay, so I didn't leave myself space there. Oh, that fit. There we go. So that's what you want to say for part A. I know I was quite verbose about that, but it's good to be oriented, right? So again, he's correct. They're not 2 real numbers that are identical and multiplied negative 100. Can't do it. 10 times 10 is 100, and 10 times 10 is 100. But you can't multiply 2 identical real numbers to get negative 100. It just can't happen. Yeah. Yeah, that too. Mm-hmm. Yeah, or actually, I like what you said. That works too. Yeah, totally. Yep. Now this one, I can figure out that this is true. Well, if I do negative 100 squared, and then raise to the 1/4 power, that's going to be 10,000 raised to the 1/4 power, or the 4th root, which equals 10. So he is correct. That's kind of interesting, right? That technically is not wrong. But then he says that doesn't make any sense because 2/4 can reduce to 1/2, so they should give the same answer. It's kind of interesting, actually. And to be honest, I'm not really sure what to think of it. I don't know. What do you guys think? Because they should give the same answer, but they don't. What happens when you square something? It goes from negative to what? So it's just interesting. Even though 2/4, 1/2 are the same, it kind of tells us that maybe we can't reduce to fractions when they're an exponent. Maybe, I don't know. I'm not sure. It's kind of interesting. I'm not 100% sure. That's just more to think about. Nothing on a test or anything like that. So, okay, we'll go and stop there because we have about 10 more minutes left. Yeah. 2/4, really?
Yeah.
True. If you do put because the calculus is actually reducing it. Yeah, it's kind of interesting. I still don't really know. Okay, let's stop the